Hello everyone. Today I'll be deriving the solution to the Buffon's needle problem in the case that the needle is shorter than the distance between the lines. This solution involves slightly more complex mathematical concepts, but hopefully I can explain it well enough that you can still understand. Before I go into the solution, I have to first explain a couple concepts from probability and calculus. The first major concept is the probability density function, or which I will call the PDF from now on. Here are some common forms of PDFs. I will explain to you the function of PDFs using the uniform PDF. With these functions, you can find the probability that the variable exists within an interval. So if I wanted to find the probability that x is between the points C and D, I have to find the area underneath the PDF. As you can see here, it's just a square, and the area is the width times the height, so D minus C times H. So that's the gist of the PDFs. The important property about PDFs is that their total area under the curve must become 1. So to find h in this case, you must find the total area. So we have b minus a times h equals 1, therefore h equals 1 over b minus a. And the PDF is 1 over b minus a between the values that x exists and 0 otherwise. So if you were to find the total area, it would become 1. In some cases, the PDF may be too complex to find the area under the curve using simple geometry. So in this case, you have to resort to using an integral. And this is a concept from calculus, and if you don't know calculus, I would highly recommend learning it. But basically what it does is, if you integrate a function between 2 points, like C and D, it will result in the area underneath the curve, and here is the notation for it. Integrate f of x between C and D, and it results in the probability that x is in that interval. And with this exponential PDF, x exists between 0 and infinity, so if you integrate between 0 and infinity, it should equal 1. Now for the derivation. Let's say every time you throw the needle, you know these two things, x and theta. X is the distance between the center of the needle to the closest line, which means that x can only take values between 0 and d over 2. And theta is the acute angle between the needle and the lines. So that means once the needle goes vertical, it takes the value from the other side, like in this example over here. And now, since the throws must be totally random, that means that x and theta are uniformly distributed, which means it's a uniform PDF. So we can actually find the PDFs for these two values. So x can take values between d over 2 and 0, and theta can take values between 0 and pi over 2, which is 90 degrees. And so in my example from the uniform PDF, we have to find h for both. So for x, we have h times d over 2 equals 1, therefore h equals 2 over d. So the PDF is 2 over d for where x exists and 0 otherwise. And then for theta, the same thing, pi over 2 times h equals 1, h equals 2 over pi. So f of theta is 2 over pi where theta exists and 0 otherwise. But we really want to find the joint PDF, which is the combination of the two. And since these two values, x and theta, are independent, we can just multiply them together to find the total space that these two things take up. So we have 2 over d times 2 over pi. So f of x and theta becomes 4 over pi d, where x and theta both exist and 0 otherwise. So here's another good way of looking at the joint PDF. So here we have a 2D graph of x and theta can be between 0 and pi over 2, and x can be between 0 and d over 2. And the total area of that are the two side lengths multiplying, so that's pi d over 4. And since the area must integrate to 1 the PDF is 1 over that, so it's 4 over pi times d. And as you can see, this integral here becomes 1, so it's a valid PDF. Finally, we can solve our problem. We have to determine what values that x and theta can take when the stick is crossing the line, and then integrate over the area of those values. Now, using trigonometry, we can determine the length of this line here, which is L over 2 times sine of theta. And if x is less than that value, that means that the stick is crossing the line. In this example, L over 2 sine theta is here, and x would actually be greater than that value from here to here, so that means the stick is not crossing the line. And theta can be any value because no matter what orientation, there's always a possibility of the stick crossing the line. So now let's integrate over those values. So x goes from 0 to L over 2 sine theta, and theta goes from 0 to pi over 2. And then going through the solution here, and then we get 2L over pi times d. So the probability of a crossing is 2 times L over pi times d. And yeah, so I hope this made a lot of sense, and if not, just let me know. Thanks for watching.